Hello and welcome to another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson 4 on division with decimals. Alright, now this is a skill that you learned in 6th grade, and we're going to review it now because there's going to be times in this course where we're going to want to do some division involving decimals. And we really want to also take a look in this lesson at how fractions, right, which are numbers, have a decimal representation that we can get by using division. Anyway, let's launch right into it and do some review on how to do division that involves decimals. Here we go. Exercise number 1, let's do a little basic decimal review. Place each of the following decimals in fraction form using a denominator that is a power of 10. Do not simplify. All right, so in other words, decimals are all really about fractions that have denominators of 10, 100, 1,000, 10,000, 100,000, etc. Those are powers of 10. So for example, in letter A, 0.2, right, or 2/10, is simply the same, literally, as this fraction. These two are the same number. They represent the same quantity, all right? So what would 1.9 be? Well, if you think a little bit about how division with 10 goes, right? This is 1 and 9/10, but 1 is the same as 10/10 plus 9/10, so 1.9 is 19/10. All right, let's get some hundredths involved, right? Right here, when we would read that, we would normally read it as 37 hundredths. You could also read it as 3/10 and 7/100ths. So let's take a look at that really quick, right? We could think about this as 3/10 plus another 7/100ths, but 3/10, right, if we think about equivalent fractions, is the same as 30/100ths, and therefore 0.37 is the same as 37/100ths. Circle it so you can see it. All right, so easy enough. That last one, very, very similar to a combination of sort of letter B and letter C. 2.98, right, would be the same as 298/100ths. Okay, now you want to be able to do that because the idea is that you already know how to divide fractions, right? Since decimals are simply sort of fractions with denominators of 10, 100, 1,000, etc., if we can divide fractions, we should be able to divide decimals. So let's keep going with a little decimal division review. All right. Now, there's a lot of different types of decimal division review. You know, one piece of decimal division is simply when you divide two whole numbers and the result involves a decimal. So let's take a look at how to do that in exercise number 2. When Nora hit Burger to Go, she spent $42 on 8 hamburgers that each cost the same amount. Letter A asks us to evaluate the following quotient to find out how much each burger cost. Right? Now, this just should totally make sense, right? I mean, we've got 42 total dollars, and we're dividing by 8. Now, because you've worked with money a lot, it's probably very natural for you to think about this as 42.00. Keep in mind, though, I could, if I really needed to, keep writing the zeros on and on and on, because that just means, oh, I have 0/10, 0/100ths, 0/1000ths, 0/10,000ths, etc. Yeah, starts to get a little bit bad after a while. So anyway, let's review how to divide 42.000000 by 8. Let's do this. Now, one thing that's nice about this is we just sort of move the decimal point up here to the top of the division, and we say, all right, what is, how many times does 8 go into 42? Well, 8 goes into 42. Now I'm moving my decimal point around 5 times, right? That leaves us with 40. We do the subtraction, bring the 2 down, and now we drop this 0. 8 goes into 20, well, that's going to be 2 times, right? That's going to give us 16. We do the subtraction again, get 4, drop another 0 down, and 8 goes into 40 5 times. So each hamburger costs $5.25. Now, the great thing, we just have to simply keep track of where that decimal is and then add as many zeros as we need to until we've got no remainder left. Sorry, I should have put that 40 there, subtract, and get that 0 remainder. Now, letter B says, check your answer from letter A by using a product. Awesome. So remember, we can check any division problem by doing a multiplication problem. Specifically, what we want to do is we want to see if we buy 8 hamburgers for $5.25 per hamburger, do we spend $42? Now, we reviewed multiplying decimals back in lesson number 1. Why don't you pause the video now and do 525 times 8 and see if you get that 42. All right, let's go through it together. Here we are, 525 times 8. All right, 8 times 5 is 40. Carry the 4, 8 times 2 is 16, plus 4 is 20. Carry the 2, 8 times 5 is 40, plus 2 is 47. Whoop, nope, not 47. 8 times 5 is 40, plus 2 is 42. That would not have been a very good check. And keep in mind now, right, because I've got 2 decimal places in this decimal part of the product, I'm going to have 2 decimal places here, which means I've got my $42. The important thing here is, of course, again, the fact that we can check the division by using a product. All right, let's keep moving on. Exercise number 3. All right, so what we want to do is find each of the following quotients. Keep in mind that quotient, that word, is simply the result that we get when we divide 2 numbers. All right, now, when we do these division problems, and these are identical to the last one, each decimal will do what's called terminate. We're going to talk about and see situations where decimals don't terminate a little bit later on in the lesson, but now what we're really doing is just what we did in the last problem. Let's do letter A together, and then I'm going to have you do letter B and letter C on your own. All right, let's take a look at letter A. 213 divided by 6. All right, now I'm going to extend my division bar just a little bit here. All right. And what I'm going to do is I'm going to say, how many times does 6 go into 21? Well, that's 3 times, which leaves me with 18. I do my subtraction. 21 minus 18 is 3. I drop this other 3, and I get 33. How many times does 6 go into 33? Well, that's going to be 5 times. That's going to leave me with 30. All right, I'm going to drop, subtract, and get a 3. All right. And now what's going to happen is I'm going to extend my decimal by putting a 0.0 on, drop that 0 down. Now I say, how many times does 6 go into 30? That decimal now is up there. That's 5 times. And I run out of space, subtract, and get 0. Needed to space that out a little bit more or just write smaller. Either way, the key here is the fact that I put that 0.0 on because I needed to drop down another 0 to keep going. So I ended up having 35.5. What I'd like you to do is practice this in letter B and letter C. Again, you can always add more zeros after the 6 here, or add more zeros after the 4 here in order to keep doing the division until you have a 0 remainder. Why don't you go ahead and pause the video now and take a little bit of practice time. All right, let's do it. 25.6 divided by 8. Here we go. 8 goes into 25 3 times, giving me 24. I subtract, and I get 1, and I drop the 6. This one should have been pretty easy. 8 goes into 16 2 times. So when I subtract, I get a remainder of 0. My final answer there, 3.2. Now a little bit more challenging is 16 divided into 28.4, or 284, sorry about that. 16 goes into 28 1 time, right? So that when I subtract, I'm going to get 12. I drop my 4 down to get 124. Now I might have to think and play around with this a little bit. Is it 7 times? Is it 6 times? Is it 8 times? Let me try 7. Right, 7 times 6 is 42. Carry the 4. 7 times 1 is 7 plus 4 is 11. And when I do that subtraction, I find that I get 12. Since 12 is smaller than 16, I know I made the right call. So I'm going to tack on a 0.0, drop that 0 down for 120. 16 goes into 120. All right, again, we're going to go 7. 7 times 16 is again 112. I subtract again, I get 8. I put another 0 on there, drop it down, Now how many times does 16 go into 80? That's going to be 5 times. 5 times 6 is 30. Carry the 3, cross out that 4 so it's not confusing. 5 times 1 is 5, plus 3 is 8. And there we go, 0 remainder. So 17.75. So hopefully you got 3.2 here and 17.75 there. Letter D asks us to check our answer to letter C using a product. Again, the idea here is that we can take our 17.75, multiply it by 16 to see if we get 284. Pause the video now and get some practice with decimal multiplication. All right, let's do it. 17.75 times 16. All right, let's go through it. 6 times 5 is 30. Carry the 3. 6 times 7, 42. Plus 3 gives me 45. I got to watch out not to do this too quick. 6 times 7 is 42. Plus 6 is 46. And 6 times 1 is 6. Plus 4 gives me 10. I'm going to erase all these little numbers because I don't want them to confuse you. Now I'm going to put down another 0. This one's going to be easy. 1 times 5 is 5. 1 times 7 is 7. 1 times 7 is 7. 1 times 1 is 1. Let's do our addition now. 0, 0. Carry the 1. 7 and 6 is 13. Plus 1 is 14. Carry the 1. 8 and 2. Now, of course, we say, all right, that 17.75 has got a really small decimal that's hard to see. It's got 2 decimal places. I want 2 decimal places here, which then is a good check. Because I was supposed to have 284, and I did. All right, so multiplying to check division. Let's keep moving on with some more division involving decimals. All right, what do we have? Dividing 2 decimals. All right, so now we get to the heart of it. Before, we were dividing maybe a decimal by a whole number to get another decimal, or maybe a whole number by a whole number that gave us decimals. But now we want to divide 2 quantities that both have decimals in them, and we want to remember how we did that from last year. So let's take a look at exercise number 4. Consider the division problem 29.6 divided by 0.8. Letter A, rewrite this as the division of 2 fractions. Evaluate this quotient. All right, let's do it. So remember, decimals are just a fancy way of actually writing down fractions with denominators of 10, 100, etc. So 29.6, right, is actually 296 over 10. Likewise, 0.8 is 8 over 10. So saying 29.6 divided by 0.8 is the same as saying 296 tenths divided by 8 tenths. Now we can keep change or keep change flip, whatever, and we can rewrite this as 296 divided by 10 times 10 divided by 8. Now, if we're looking to multiply 2 fractions and use a little cross cancellation, you don't get any better than this because the 10s cancel each other out, right? Giving us 1 and 1, and that gives us 296 divided by 8. Now, let's just pause for a minute and kind of take a look at this. 29.6 divided by 0.8, just based on what we know about fractions and dividing fractions, has become 296 divided by 8. That look awfully similar. It's like we took this thing and just moved the decimal place 1 to the right, took this one, moved the decimal place 1 to the right, to come up with an equivalent division problem, which we could now just do by doing 296 divided by 8. That's going to give us 3, 24. That's going to give us 56, and that's 7. So I get 37. All right, that's easy enough. This, though, explains the standard algorithm for dividing decimals, and that we're going to review in letter B. Okay? Now, use the standard algorithm of moving the decimal point to perform the division. Now, I want you to think about this for a moment. On the last page, we had no problem when we took a number that may have had a decimal in it or may not have, and we divided by a whole number. So the real key when we have a situation like this is to move the decimal place on what we're dividing by, and this the same number of places to make this into a whole number. Whether this is a whole number or not is completely irrelevant, but we want this to be a whole number. So in other words, what we do is we take that decimal place, we move it 1 unit to the right there, 1 unit to the right there, and it simply becomes this. Now, we already saw what the answer to that is. It's 37, and there's no need to do it again. But the standard algorithm says move the decimal place, typically to the right, as many places as you need to until what you're dividing by is a whole number. This doesn't have to be a whole number at all. Don't worry about it being a whole number, but get this to be a whole number, and then we can do dividing decimals just the way we did it on the last page. And let's get some practice with that in the next exercise. All right, exercise number 5. Find each of the following quotients. Each answer will result in either a whole number or a terminating decimal. All right, again, we'll get to non-terminating decimals in just a bit, but we want to find each of the following quotients. So let's do letter A together and then have you practice on letter B and the tough one, letter C, on your own. Let's do letter A together. All right, so the idea is I don't really want to divide by 1.2, but I don't mind dividing by 12. So I'm going to move that decimal place 1 unit to the right, and I'm going to move this one 1 unit to the right, and that will literally give me the same answer. So I think, how many times does 12 go into 31? That's going to be 2 times, and that will give me 24. When I subtract, 31 minus 24 is 7. I then drop my 2 down. I think, how many times does 12 go into 72? I believe that's 6, but let me check. 6 times 2 is 12. Carry the 1. 6 times 1 is 6, plus 1 is 7. Subtract, and I get a remainder of 0. Now, unlike multiplication with decimals, there's nothing that I need to do now. I don't need to look at my answer of 26 and think, oh, how many decimals are there up here? No, the answer is 26, literally. 31.2 divided by 1.2 is 26, and we could easily check it using multiplication. It's kind of a pain, but we could do it. So what I'd like you to do now is do the same procedure in letter B and letter C. That's going to be a little bit more challenging, and see what quotients you get, and then we'll come back and do them together. All right, well, letter B is not too different from letter A, but let's go through it. Right, we just need to move that decimal place 1 unit to the right in both cases. So we'll have 4 divided into 35.6. All right, so I say, how many times does 4 go into 35? That's going to be 8 times, leaving me with 32. When I do the subtraction, we'll get 36 as we drop the 6 down. We got to move that decimal point up. 4 goes into 36 9 times. That gives me 36. Subtract, remainder of 0. 8.9. All right, now here comes the tough one. And it's tough for a couple reasons. Number one, because we have to move this decimal place 2 units to the right. And then we're dividing by 284, which is a little bit of a larger number to have to deal with. But let's do it all together. So I'm going to move this decimal place now 2 units to the right. I've got to do the same thing here, and my magic red pen just showed up for the first time. All right, so here we go. We have 284 now divided into 1050.8. All right, so this is a little bit trickier, but here's a little bit of kind of like estimation work, right? 284 is relatively close to 300. And of course, this is relatively close to 1,000. So if I think about 3 times 300, hopefully it occurs to me that that is 900, right? And 900 is probably close enough to 1050 that that's my winner. In other words, I'm going to try for 3 as my first number. So let's do that. All right, so 3 times 4 is 12, carry the 1. 3 times 8 is 24, plus 1 is 25. And 3 times 2 is 6, plus another 2 is 8. Now the question is, was that big enough? Or should I have gone to 4? Well, let's do the subtraction. The subtraction here is a little bit obnoxious because we're going to have to borrow 1 there. We're going to have that. Then we're going to have to borrow 1 there and put 1 there. So we have 9 minus 8, which is 1. 14 minus 5, which is 9. 10 minus 2, which is 8. All right, and in fact, that's enough to show me that it was the right choice because 198 is less than 284. Now, how many times does 284 go into 1,988? Well, that's going to be 7 times. And again, I'm going to erase all of those. 7 times 4 is 28. Carry the 2. 7 times 8 is 56. Plus 2 is 58. Carry the 5. 7 times 2 is 14. Plus 5 is 19. Subtract remainder of 0. All right. 3.7. Ugly division by decimals. I mean, it's not really all that harder than any other type of division. It's just that you have to put in that first step where you make sure that what you are dividing by, known as the divisor, not surprisingly, is a whole number, right? You move the number of decimal places, you move as many as you need to the right to make sure it's a whole number. You do the same thing to what you're dividing into. Okay, let's keep going. Last set of problems, here we go. Exercise number 6, an applied problem. DeMarco is trying to determine how many pennies he has without having to count them. He first weighs out 20 pennies and finds they have a total weight of 54 grams. He then weighs out all the pennies and finds they have a total weight of 918 grams. All right, so letter A asks us to determine how much a single penny weighs, i.e. the grams per penny. Okay, what I'd like you to do is pause the video and try to use the information that you have to figure out the weight of a single penny. Do that now. All right, one thing that's nice about rates is if you see something like grams per penny, it means we want to divide the grams by the number of pennies. And what we know is that 20 pennies weighs 54 grams. So if we want to figure out how many grams a single penny weighs, what we're going to do is we're going to take those 54 grams and we're going to divide by 20. So our first place with decimals, I'm going to put a little 0.0 there. 20 goes into 54 2 times. That leaves me with 40. When I do my subtraction, I'll have 14, and then I'll drop down a 0. And then 20 goes into 140 7 times. Subtract, and I get 0. So each penny weighs 2.7 grams. All right, 2.7 grams per penny. Now let's take a look at letter B. Use your answer from A to determine how many pennies DeMarco has. All right. So think about how you can use this answer along with information from what you're given to figure out the total number of pennies that DeMarco has. All right, well, it's this simple. We know he's got a total of 918 grams of weight. And we know that we have 2.7 grams per penny, and this gets into that interpretation of division, right? It's sort of like I've got buckets, and those buckets hold 2.7 something, right? And I've got a total of 918 something, specifically grams. I want to know how many buckets I have, how many pennies I have. So I'm going to divide 918 grams by 2.7 grams per penny. Let's do that to see how much money DeMarco has. All right, so he has 918 divided by 2.7. But this is where we're going to use our algorithm and move that decimal point one place to the right. So instead of having 918 divided by 2.7, we have 9,180 divided by 27. So here we go. We're going to think about this as how many times does 27 go into 91? That should be 3 times. 3 times 7 is 21. Carry the 2. 3 times 2 is 6. Plus 2 more gives me 81. All right, so now I do my subtraction. 91 minus 81 is 10. Awesome, I drop my 8 down. Okay, but I get rid of that 2. Now I have to think about how many times 27 goes into 108. I believe that's going to now be 4 times. 4 times 7 is 28. Carry the 2. 4 times 2 is 8, plus another 2 is 10. Oh, nice. Now, this is a little weird. All right. Let's pause just for a minute, because a lot of students might get to this point and they might say, oh, the answer is 34. Well, clearly DeMarco has way, way more than 34 pennies, right? I mean, 20 pennies weighed 54 grams. Clearly, 34 pennies can't weigh 918 grams. It just doesn't make any sense. So the key here is that since I haven't dropped that last 0 down, I'm not quite done. Okay, I've got to bring that last one down. And when I do, of course, now I'm asking the question, how many times does 27 divide into 0? And that's 0 times. And yeah, that looks a little funny, 0, 0 minus 0, which is 0, but that's the way it goes. All right, so 340 pennies that DeMarco has. This is kind of a good way to figure out how much change you have in a jar if you know various things, how much the change weighs, if they got to all be the same kind of coin, etc. But it's a neat way to figure out how much we have. All right, let's wrap this up. So today, we saw a lot of different things with division with decimals. We saw how we take a whole number and divide it by another whole number where the result has a decimal portion of it. We also saw how to divide two numbers that both have decimals in them and why that all works. Okay, we're going to use this as we look at connections between decimals and fractions in an upcoming lesson. For now, though, just get some practice on it on the homework. Thank you for joining me for another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.